Today we are going to start the coordinate geometry. In coordinate geometry, we define the position of points on a plane known as the coordinate plane with the help of an ordered pair of numbers called coordinates. The coordinate plane contains two axes, the horizontal axis called x-axis and the vertical axis called y-axis running through it. The intersection point of the axis is called origin. The location of a point on plane is given by two numbers in a small bracket separated by comma. On the x-axis, values to the right of origin are positive and those to the left are negative as shown. Similarly, y-axis, values above the origin are positive and those below are negative. Because of this, the coordinates of points lying in this first quadrant will have a positive x-coordinate and a positive y-coordinate expressed as xy. For a point lying here in second quadrant, the x-coordinate will be negative and the y-coordinate will be positive, resulting in the coordinates being minus x, y. Similarly, the coordinates of a point lying in third quadrant here will be minus x, minus y, and those of a point lying here in fourth quadrant will be x minus y. Let's take this point for instance. The location of this point P will be given by coordinates represented as P, 5, 3, as we have to move 5 units on the x-axis from origin, that is 1, 2, 3, 4 and 5, and 3 units on the y-axis from origin, that is 1, 2 and 3. Let's not forget that to write it as 3, 5 would be wrong, as the x-coordinate has to be written first in order, and 3, 5 would mean this point instead. Let's now move on to the distance formula. The distance formula is used to find out the distances between two points represented as A, x1, y1, B, x2, y2. Let's try to find out the distances between these points A and B. It is represented by the length of line AB. Let's construct a line from x1 to x2 like so and call it AT, and a line from y1 to y2 like so and call it BT. We can see we have constructed a triangle AVT, which is a right angle triangle. Let's extend TA to R and BT to S. We can see that the lengths of lines have come out to be RA equals to x1, RT equals to x2, TS equals to y1, BS equals to y2. Therefore, the length of AT becomes RT minus RA equals to x2 minus x1. And the length of BT becomes BS minus TS equals to y2 minus y1. We know as per Pythagoras theorem, the square of hypotenuse is equal to the sum of squares of perpendicular and base. In this triangle APT, AV is the hypotenuse. Therefore, AV square equals to AT square plus BT square. Or AV square equals to x2 minus x1 whole square plus y2 minus y1 whole square, or AV equals to root under x2 minus x1 whole square plus y2 minus y1 whole square. Therefore, the distance between two points is given by D equals to root under x2 minus x1 whole square plus y2 minus y1 whole square. This is true for points lying in any quadrant and with any slope. Let's take an example of points C, 2, 6 and D, 5, minus 3. Let's take C, 2, 6 for x1, y1 and D, 5, minus 3 for x2, y2. We know from the distance formula, the distance between two points will be root under x2 minus x1 whole square plus y2 minus y1 whole square. Therefore, CD will be root under 5 minus 2 whole square plus minus 3 minus 6 whole square equals to root under 9 plus 81 equals to root under 90. We can use this method to find out the distance between any two points with known coordinates. Thanks for watching. Like and subscribe for more educational videos.